project on model adequacy and diversification with you. So, as you probably know, in diversification analyses, models are pretty central. We use them to estimate rates. We use them to simulate trees to get like null distributions. We use them to compare them and test hypotheses. But the question is, of course, how confident can we be in those models? We are getting increasingly aware and also active about the flaws our models have, because all have them, of course. So this is a random selection of things people have done in that respect, going from are we accurate, are we using them the right way. The thing we want to look at right now is model adequacy. So no matter how well the model performs, is it actually the right model to use for the questions we want to answer? And the way we're doing is right now is pretty simple. We take an empirical tree, we estimate its parameters, for example, speciation and extinction rate, and then we simulate 1,000 trees using those parameters. And then we compare them. So for now, I just did it with 6 trees of different sizes and under 3 simple models: birth death, time-dependent birth death, and trait-dependent diversification. Now, let's have a look at birth death first. The way we compare them is by looking at the branch length distribution. So all the black lines here are the branch length distributions of simulated trees, and the colorful one is our actual empirical tree. And as you can see here, and actually with all the other trees as well, more or less, it seems like the branch lengths of the simulations are pretty much matching the one of the empirical tree. However, if we split this up into terminal branches and internal branches, we actually see that while the terminals still seem to kind of match in terms of simulation and empirical, we have some clear outliers here when we look at the internal branches. Some are overrepresented in our simulations, some are underrepresented compared to the empirical tree. And again, we see this in pretty much every tree I ran so far. Now, here to kind of give you an idea of which branches those are, this is one of the empirical trees, and the blue branches are underrepresented in the simulation, and the red ones are overrepresented in the simulation. And interestingly, what we see in this case here is something that Tanja Stadler has described already in one of her recent papers, and it's that our simulated trees tend to be less unbalanced than our real trees. So if we look at time-dependent diversification, we see pretty much the same, except that we have more cases where actually also the internal branches match between simulation and empirical tree. And if we look at trait dependence for the ones where we did that, it's interesting because we actually see that there's a much better match, which makes sense because we have more parameters, and so the model is much more flexible to match our actual empirical tree. From there, we would like to go ahead and include a lot more models, a lot more complex models, and more empirical trees, and also take things into account like fossils and incomplete sampling and different tree sizes and tree ages, and because those things might be things that are behind the patterns that we see now.